Hello and welcome. Today we're going to focus on arithmetic and geometric sequences. In this first video, I'm going to talk about how you can solve problems using arithmetic sequences in series. The first thing that I want to direct your attention to is in the book, in chapter 13, is where you'll find the information about series and sequences. Now, an arithmetic sequence is something that is linear that you probably have seen, like a linear equation y equals mx plus b is an arithmetic sequence because it goes up by a common difference. Now, there's a formula to find the common difference here, and then there's a formula to find to define the sequence, and then there's a formula to find the sum, depending on what we're working on. And so we might have to use these together to find the answers to some of the questions that we're being asked. On the in-class worksheet, we have questions 22 through 24 that deal with arithmetic sequences. And I'm going to start with 22. Question 22 says, for a given arithmetic sequence, the 32nd term is A32. A32 is equal to 124. The 93rd term, which we call A93, is equal to 307. And they want us to find the 10th value. Well, we know that we have this information that A sub n is equal to A sub 1 plus n minus 1 times d, where this is the nth term, this is the first term, this is the number or index, and then this is the common difference. And a sequence can also be defined recursively using this formula, where the nth term is equal to the n minus 1 term plus the common difference. So this is a recursive formula. Now, in order to find the 10th term, if I'm using this equation here, I need to know the first term, the common difference, and what my n is. Well, here I know that n is 10, but I don't know the first term. I know that n is 10, and I don't know the common difference. So first I want to find the common difference. If I know that the 93rd term is 307, and the 32nd term is 124, well, what's the difference between 93 and 32? 93 minus 32 is 61, and the difference between 307 and 124 is 183. So for every 61 times, or for 61 terms, I increased 183. Well, how much is that per one term? So if I divide 183 by 61, I get 3, which is my common difference. Okay, now I can go back into this formula here, and I can fill in 3 for my common difference. But I still don't know what my first term is. I don't know what A10 is in this case, so I need to find it. But I do have 2 points that I can use here. This is kind of like when we're trying to find the formula for a linear equation in slope-intercept form, where we find slope and then we have to find intercept. We use a point to do that. So we're going to use either the point A93 or the 93rd term or the 32nd term to find what my first term is. This missing piece is going to be able to help us find the 10th term. Using that idea, I'm going to take 93, and the 93rd term is equal to the first term plus n, which is 93 in this case, minus 1, times a common difference of 3. Now, 93 minus 1, A93 is 307. 93 minus 1 is 92, times 3. We have 307 is equal to the first term plus 276. If I subtract 276, 307 minus 276 is 31. And that's our first term. Now that we have our first term, our common difference, and I know that I want to find the 10th term, I can replace A sub 1 here with 31. Now I just evaluate. A sub 10 is equal to 31 plus 10 minus 1 is 9 times 3. I'm going to erase this to give us a little bit more room. And finally, a sub 10 is equal to 31 plus 27, which is equal to 58. And that's our final answer. And I mentioned this multiple times in class that this is a meaty problem, which means it's thick. It has a lot that it's asking you to do. So just know that we need to know where to start and take it step by step. Question 23 asks us to write an explicit formula for the nth term. An explicit formula is here, which is different than the recursive formula. We know the first term, we can find the common difference, and we go from there. So for this term right here, a sub 1 is 23. Now what's happening as I go from 23 to 19 to 15 to 11, it's going down by 4. So that means our common difference is -4. We also know the formula that's explicit as a sub n equals a sub 1 plus n minus 1 times d. A sub 1 is 23. We're not using an n at this point, and d is -4. You could write your formula like that, or you could distribute here. A sub n equals 23. -4 times n is -4n, and -4 times -1 is +4, which leads us to a sub n is equal to 27 minus 4n. That's the same thing as -4n plus 27. Okay. Now on my last two, I'm asked to compute the sums below. So I'm not using that formula that's explicit or recursive. What I'm using is the sum. That formula here, S sub n is equal to n over 2 times a1 plus a sub n. Writing that down, S sub n is equal to n over 2 times a1 plus a sub n, or a sub 1. What I need here is I need to know how many terms there are, I need to know what the first term is, and I need to know what the last term is. Here, I know what the first term is, I know what the last term is, but I don't know how many terms there are. So I need to find that out. In B, I have what n is, but I need to find a1, or a sub 1 and a sub 2, or a sub n. In the second term, I need to figure out what the first and the nth term is because I know what n is, and we'll talk about that. Let's start with A, where we know the first term is 9, and the nth term is -276, but I don't know what n is. Let's think about the common differences. What's happening here as I go from 9 to 6 to 3? I'm decreasing. So using the same idea as above, I can find n. By knowing what the first term is, I can say that here I have a sub n equals a sub 1 plus n minus 1 d. I know the first term, I know the common difference, and I know what the last term value is. I'm going to go ahead and make this -276 equals 9 plus unknown n times a common difference of -3. And then I solve this equation. -3 times -3 times n and -3 times -1. I get -276 equals 9 plus 3 minus 3n. -3 times -1 is +3. -3 times n is -3n. -276 equals 12 minus 3n. If I subtract 12 from both sides, I get -288 equals -3n. Dividing both sides by -3, I have n equals a positive 96. Now that I know the first and the last term and how many terms there are, I can solve this equation. The sum is equal to 96n, 96 is n, over 2 times 9 plus -276. 9 plus -276 times 48, that's equal to -12,816. For part B, the notation here is saying the sum of the expression 4j plus 11 starting at j equals 1 to 120. What that means is I take negative 4 times j equals 1 plus 11, and then I add negative 4 times 2 plus 11, all the way up to negative 4 times 120 plus 11. But I don't want to list 120 terms and do that. I want to use the formula. Well, what is the first term? And what is the 120th term? Negative 4 times 1 is negative 4, plus 11 is equal to 7. That means that A sub 1 is 7. Negative 4 times 120 is negative 480, plus 11 is equal to negative 469. That means that the 120th term is negative 469. Plugging that into the formula, the sum of the sequence is equal to the number of terms divided by 2 times the first term plus the last term. That's equal to 120 over 2 times 7 plus negative 469. That's equal to 60 times negative 462, which is equal to negative 27,720. Thank you for watching.